Hi everyone. So today I want to show you a thing called computational fluid dynamics. This is a simulation um, made by Boeing. That's right, the company that makes the airplanes. And I believe it's a visualization of the aerodynamics of a telescope. Like it's a telescope enclosure, a building, or a proposed building. And anyway, what we're seeing a visualization of the airflow around this building, as indicated by all of these little arrows. Now, if we look really, really close at this, I wonder if this thing lets me zoom in. Here we are. Yeah. Equals. You can see there's all these three-dimensional arrows. And this one's going further back into space. You can see it's curling around and it's coming towards us. And you can also see here the color of the arrows and the length of the arrows is telling us something about the actual speed, which is measured in meters per second. I guess that's the velocity magnitude. And so every single one of these little arrows in the airflow, it's a fluid simulation. It's a fluid motion simulation. I call these things fluid vectors. There's probably an actual official name for them, but I just like to call them fluid motion vectors, or fluid vectors for shorts. And this is something I would like for people to really, etch this into your mind, because this is going to be pretty important. Just remember how those arrows are, right? Look at all those arrows traveling off into the distance. Every single one of these fluid vectors represents the direction and speed of air moving at a particular point in space. And this is how I visualize every single line that I draw. So, if you look at these examples here, I've done pretty much the same thing. Every single line that I've drawn is visualized by a fluid motion vector. I just simply add an arrowhead to all of these, and you can see there's a direction where they go away or towards us, or sometimes they go across the field of vision. But this is how I visualize every single line that I draw. This is not a new thing for me, but I wanted to show you guys that diagram just so when you see me drawing lines, you understand what it means when you draw a line. You have to make every single line count. So if I draw a series of lines like this, and you can see that I am purposefully breaking these lines, I'm pretty much doing the whole fluid motion vector thing. Each one of these lines is a three-dimensional object. This is this is a big thing. Most times, in the past, or I say at present even, at the time of this recording, people teach drawing by saying, oh, you've got to learn boxes, you've got to learn cylinders, you've got to learn cubes and cones. And I think this goes one step deeper, where you look at the individual line. You have to treat each individual line as a three-dimensional object. And if you learn how to draw fluid motion vectors, you can draw all the boxes you want using these. This is a more foundational and more fundamental skill than drawing with just boxes, or drawing with cylinders, or drawing with any of these geometric primitives. Because the reason why I say it's more foundational is because this is much more atomic. This is the component. You can build upon this. And one of the reasons why I keep making these foundational videos is because the other ones just don't work. People watch the videos, they don't get better. They come back to me and I look at their work, and they say, "Oh, I've watched your video," and I'm like, "Yeah, but you don't get it because you're not drawing well." So rather than moving on and showing all these advanced techniques on how to paint, we're right back down here in the foundations and the basics, because this, I think, is actually this is something that I have not seen in any books. I have not seen fluid motion vectors being explained, not like this, not with the arrowheads. So you can see how these fluid motion vectors, they go further and further away into space, and then they rotate, and then they go kind of across like that. This is how every single line needs to be drawn. So there's a number of ways in which they can be expressed as arcs. I can use a series of these lines now. Now they kind of go towards a vanishing point. There's a reason also I don't show people how to draw with vanishing points either. It's just because they're not very effective, right? I've seen lots of people drawing. They're like, yeah, I do all the vanishing points, yet my drawing still sucks. It's not helpful. It's not foundational enough. They're missing something foundational. Like there's so many people who will they say, oh, I guess I just need more practice, right? But yeah, you're practicing, but I mean, you're still not getting better. It's because you're missing something. You're not practicing the right thing. You're missing the foundation. You haven't reached the underlying issue, the underlying problem. You're not getting the one thing that you're missing. So, drawing converging lines like that, you can draw parallel lines. Now it feels like they're flat. We draw them converging. So, what I would advocate for people who are new to drawing is not drawing boxes and drawing cylinders or drawing any of these fundamental objects, these geometric primitives. I would say learn to draw fluid motion vectors. And as the, people say, what should I practice? I say anything will do. Anything will do. You can draw. I'm going to draw an ellipse using FMVs. And it just comes down to getting the feel for it. Just draw as much as you can and get the feel for it. Draw fluid motion vectors. You don't have to add the arrowheads on them, mind you. But you do have to think about it, right? You do have to think about how, where are these things in space? And try to build three-dimensional objects using these fluid motion vectors. And the broken line, the nature of how I always use these broken lines is very important. Because if I do broken lines like this, it looks like fluid motion vectors. You get that 3D sense to things. But if you just draw continuous lines like this, there is no information. There's no depth information. If you break the lines, you can do this. You can draw them parallel, and they start to get closer and closer. So it's not to say that you can always move from fluid motion vectors to more finished looking things by fusing the lines together. So I can take something like this as a rough sketch, and then later on I can knock it back, and then I can use some kind of tool to fuse them together. But I find that if I want to draw some of the more minimalistic styles of characters, I can use these fluid motion vectors. Purposefully breaking up the lines. So I'm just going to draw these as a minimalistic drawing first, and then I will draw fluid motion. I will draw the arrowheads on them so that you understand what's going on. So that line is going away. That one's going away. These ones are coming towards. That one's coming towards. Starts to really feel dimensional. These are coming slightly towards us. These ones are going away from us. Even with the hair, these are going pretty much straight up. But this one here is going inwards. There's a feeling of curvature. Doesn't take a whole lot to understand this. Pretty simple stuff. So yeah, that's about it. That's all I had to show you. Guess that's all for now. Peace out.